Hello everyone. In this video we're going to be solving a radical equation. We have x squared plus 2x plus 3 equals the square root of 4 minus x squared, and we're going to be solving for x values. Or at least we're going to make an attempt, right? Now, we have a radical equation on the right hand side, and I'll be presenting two methods. So let's start with the first method. Since we have a radical, let's go ahead and square both sides. So I'm going to write the original problem and then square both sides to get rid of the radical. That's going to give us something with lots of terms, x to the fourth plus 4x squared plus 9, hopefully you know the formula, plus 4x cubed plus 6x squared plus 12x. And the right hand side, the radical just disappears like this, and we get that. Let's go ahead and put everything on the same side. We have x to the fourth plus 4x cubed, this one and this one. And if you add these two, 10x squared, bring this over, 11x squared. And then we have 12x, and then 9 minus 4 is 5. So this is our quartic equation. And yes, there's a way to solve it, even though it's not very easy to do, particularly when the solutions are not very nice. You can also try the rational root theorem, which means if there are any rational solutions, they have to be factors of 5. Of course, in this case, since this is monic, that just means that integers can be solutions. If the solutions are rational, then they're integers. Make sense? I hope it does. And the only candidates are plus minus 1 and plus minus 5. You can probably tell that a positive number is not going to be a solution because they're all plus signs. So the only two candidates left are, or candidates left are negative 1 and negative 5. And if you look at the equation carefully, if negative 1 is a solution, then the sum of the odd coefficients must equal the even coefficients, and you can quickly check that, okay? But I'm going to leave it up to you to do that, because I need to show you with the first method, a really cool method that I kind of learned from Nadia Fan. Thanks for all the beautiful comments, and keep them coming. Now, here's what we're going to do. We're going to send everything to the right-hand side except for these two terms, and I'll show you why we're doing that. So we're going to go ahead and isolate these two on the left, and then we're going to be adding something to both sides. And to find what that is, you can kind of factor out an x squared here, and notice that inside the parentheses you're missing a 4 to make it a perfect square. That just means that to this you need to add 4x squared, okay? And then of course when you do the same thing on the right hand side, you do get a quadratic, a different quadratic. But wait a minute, the left-hand side can be written as x squared plus 2x quantity squared, which is a perfect square. That's nice. So that's the first step, to make the left-hand side a perfect square. But wait a minute, the right-hand side isn't a perfect square. Houston, we have a problem, and we have a solution too. So we're going to be adding something to both sides while keeping the left-hand side a perfect square. Of course, it's going to be a different one, while making the right-hand side another perfect square. And that's when everything becomes perfect. So here's how it works. You take this, kind of think of it as a squared. You're going to add like something like a 2ab. But the expression that you're adding actually going to look like this. 2k x squared plus 2x, and then plus k squared. In other words, you have a squared. You're adding 2ak plus k squared. Does that make sense? So that this becomes x squared plus 2ka plus k squared, which is x plus, this was supposed to be an a. This is a plus k squared. Make sense? That's what I'm trying to do. So, and this is my a in this case. Okay? Sounds good? So, what am I adding to both sides? This one. So, we're going to do the same thing here. Let's write that first, and then we can distribute later. So we're adding this to both sides. I wanted to add that first because all the other terms are negative. That's why it's better to write the positive term. Doesn't matter, no big deal. But the left-hand side becomes x squared plus 2x plus k quantity squared, right? That's what happens. On the right-hand side, we have to distribute and expand this. But that's going to give us 2k minus 7 as the coefficient of x squared. And then we're going to get 4kx, another x here. So it's going to be like 4k minus 12 as the coefficient of x. And the constant is k squared minus 5. Now, if you expect to get a nice solution, k should probably be an integer on the right-hand side, and you want to make this a perfect square. So there are two ways to approach it. If this is a computation problem and it's a nice value, like k equals 1, k equals 2, k equals 5, whatever, then you could probably guess and check easily by looking at the coefficient of x, k squared, and by looking at this, because those numbers both have to be perfect squares, right? Okay. Or another alternative is, since you want the right-hand side to be a perfect square, you can set the delta equal to 0, which is going to give you a cubic equation. Then you have to solve the cubic equation by using some Italian guy's method, whoever you want to call that, okay? Cardano, Tartaglia, Ferrari. There's a couple other candidates probably. I don't know. Some guy found it at some point. And it's going to look like this. Let me show you so that what I mean by cubic, right? B squared, delta is going to be b squared minus 4ac. And this is where you get the cubic. You're going to be multiplying k squared by k. That's going to give you a cubic equation. Of course, you have to set the delta equal to 0 and then solve the cubic. Once you find the k value, you can go ahead and plug it in, or just find the answer from here, because then you'll have both sides factored, right? A perfect square equals another perfect square. And the solution, the rest is easy. But things aren't always nice, right? And you might end up with a difficult scenario. That's why I do have an alternative solution, which is the second method. By the way, I gotta tell you that we're looking for real solutions. So if there are no real solutions, again, we're in big trouble. Another issue that could come up is we're solving a quartic, which should have 4 solutions, right? But we squared both sides. So we may not have originally 4 solutions, complex or real, doesn't matter, because by squaring both sides, we may be introducing extraneous solutions. So these equations are not equivalent. They have different domains. What do I mean by that? 4 minus x squared needs to be greater or equal to 0, which means x needs to be between -2 and +2, inclusive. You see, our x is bounded, our x values. So we gotta be very careful here, and you can try this. Let me know how that goes, because I'm about to jump to the second method, because this is not very interesting, is it? Now, the second method uses a really good idea. I love it. I think it's genius. And you can make lots of problems like this one. I'm planning to make more, okay? So here's how it goes. First of all, you don't want to deal with quartic equations, especially if this was in a math contest, right? Who would want to deal with the quartic equations? They don't make you do like busy stuff, like brute force stuff like that, okay? So there's usually a genius solution or an ingenious solution, something like that. And this is how it goes. If you pay attention, that 4 minus x squared is less than or equal to 4, right? Because x squared cannot be negative. So x squared is always greater than or equal to 0. If you subtract a non-negative quantity from 4, you're probably making it smaller. Make sense? Okay. When you take the square root, this is what's going to happen. This means the square root of 4 minus x squared is going to be less than or equal to 2. Okay, you might be saying like, why is this important? Remember, I mentioned the importance of the domain early on, right? You have to check the domain. Not every x value is going to be a good one. So let's go ahead and save this. Now, let's look at the left-hand side. What do we have? A quadratic. Yay. With the quadratic, what you can do is what's called completing the square, right? So you can kind of split the 3 into 1 and 2, and this becomes a perfect square, doesn't it? It's x plus 1 quantity squared plus 2. Now, what do you know? X plus 1 squared, again, a perfect square. No square is negative. Of course, we want x to be real. Wait a minute, what happens if x is not real? We're not dealing with that, because I have another channel called aplusbi, yay, check it out, which deals with complex numbers. And if you're new to complex numbers, make sure to check it out. I also made lecture videos. And ask a lot of questions. That's how you learn, okay? Some people question like, why a 10-minute video for something like this? Okay, I could solve a problem in 2 minutes, but that's not the goal, right? The goal is to share my solution methods, my ideas. That's why videos are long. I mean, some people find it fine, and if you think it's too long, you can kind of skip to the end, or I don't know, whatever. So, non-negative expression plus 2, this is also going to be greater or equal to 2, right? Great. Now, we have an interesting scenario, because this is x squared plus 2x plus 3. So what did we get from here? We got that this expression is greater than or equal to 2, but at the same time, this expression is equal to the square root of 4 minus x squared, right? And I'm going to have to move this stuff to the right because I need more room here, okay? And we also know that the square root of 4 minus x squared is less than or equal to 2. So it kind of goes like this. Uh-oh. These two things are equal and they're squeezed between 2 and 2. Which number can be less than or equal to 2 and greater than or equal to 2? 2 only, right? Obviously. Houston, we got a solution? Maybe. Let's check it out. But they both have to be 2 in order for this to work. Okay, great. So that gives us a system of equations. This equals 2, easy, right? And this equals 2. Great, let's go ahead and solve it. Remember, this was x plus 1 squared plus 2 equals 2, which means this is 0, which means x equals -1. Beautiful, right? No, not really. Square both sides, and you're going to get this, which means x equals 0. Uh-oh, these two do not agree. What is that supposed to mean? One of them has to be greater or equal to 2. The other one has to be less than or equal to 2. So why don't they agree on the same point? Okay, let me show you. I think the graph will explain it. By the way, the graph that I made with Wolfram Alpha wasn't a good one. I realized if you graph this with Desmos, you're going to get a much better picture. And hopefully you're going to know what I'm talking about. But here's the issue. Let me show you. We found -1 and 0, right? So if you go to the graph and kind of make it a little larger, it's kind of hard to see. I know they seem to be intersecting, but they don't. You know why? Because one of them takes the maximum value at -1, the other one takes the minimum value at 0. So they arrive at the same number at different points. So they don't agree, basically. In other words, these graphs do never intersect. And again, sorry about the lousy graph by Wolfram Alpha. Desmos does a much better job. So go ahead and check it out. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out SyberMath and aplusbi. And bye-bye.